phase shift separately. All right, so we're really going to talk about amplitude, period, midline. So the first one, the amplitude of sinusoidal really means sine or cosine. They're both up and down. They're basically the same thing. We said one's just shifted left or right. So the amplitude, it is a vertical dilation. So we talked about vertical dilations, horizontal dilations, all of that, transformations. That was really tough. And if you think back to vertical dilations, those were always numbers that were multiplied in the front. Multiplied in the front was a vertical dilation. And if we kind of lay out just a generic equation with sine and cosine, that number in the front, we refer to that as A, which is really nice because amplitude starts with A. So A is the amplitude. And if it's referring to the transformation, the way we would word that is we would say it's a vertical dilation by a scale factor of whatever that number is. And what the amplitude does is it makes the graph taller or shorter. So changing the amplitude changes if the graph is taller or shorter. And actually, if you turn the page real quick, I'm going to show you kind of the way, another thing, the A could be positive, could be negative. So a basic sine or cosine function that has not had any transformations, we're only looking at a positive or negative A. This is the y-axis. This is the midline, which a very base one, it's the x-axis, but it could be somewhere else. But what the graph looks like, if it's a sine graph and your A is positive, you're gonna have a point that starts kind of here at the midline, goes up and down and then back up. So a sine with a positive A at the y-axis is going to kind of start here. If it's sine, but it's a negative A, so it's like negative sine, it's going to be upside down. A negative number in the front reflects across the x-axis, so it's going to look like this. Sometimes knowing this just helps you identify graphs or equations quickly. Now cosine on the y-axis doesn't start at the midline, it starts up here at 1. So it goes like this. So up here is like half of the hill, half of the hump, because it would go down like that. It. That's just kind of a thing to reference. But your A value kind of tells you if you focus, because it's a constant up and down all the way across. Like both sine, cosine, positive A, negative A is very similar. But if you really like focus in on the y-axis, that's kind of equations that's going to change all of that. So that's the amplitude. Functions, it's a horizontal dilation. Now, B itself is not your period. To the number right by your X is not your period. But the B comes from the period. Get your period from B, but that exact number is not your period. What you do is, well, first of all, if we're saying this horizontal dilation by a scale factor of 1 over B. If you remember, anything that happens inside with the X, any transformations, is opposite. So it's 1 over B. So I'm asking you to describe the transformations. That's how you would word it. But what we do, your period is 2 pi. That's how you find your period. So it's 2 pi over the B value. That your period is a negative number. And this last number gives us our midline. The midline. Sometimes we'll see the word shift or a vertical translation. Basically, it moves it up or down. The midline. Go back to us. How fast so depending on what the period is, it might be a really slow up and down. So think a children's roller coaster versus a really fast up and down, a more intense roller coaster. Okay, so the period affects that. To do with some examples is we're going to find piece from looking at the function. The midline or vertical shift, midline. So slightly harder. All right, so the amplitude is 13. So if I was looking at a graph, it's the top halfway down. It's of the height. So from top to bottom, how it is, okay, well, what is that exact halfway located? So the the period is 2 pi over over 2, which is what? 1 pi. Yep. If I was talking about this in terms of transformations, I would say that this is a sine function. So basically take the sine graph that we started with first thing today, and it had a horizontal dilation by a scale factor of 1/2, 1 over 2. I would say that that same sine graph also had a vertical dilation by a scale factor of 13. And then it's also asking us for frequency. Do you all remember how we find frequency? Yep, it's 1 over the period. So 1 over pi. And then the vertical shift, or also known as the midline, is -7, or you could say y equals -7. So basically we took our normal graph, we stretched it this way, we stretched it this way, and we moved it down 7. And that does make it's harder to graph those a little bit. Alright, number 2, we need to rewrite, because all of these have, it's plus d at the end. So I'm just going to rewrite this one as g of theta equals -6 cosine pi theta plus 5. I'm just moving the 5 to the end, just to keep it in the same order that the original was in. And theta is the same as x. It's just another variable. Now, amplitude is a distance, so we're really not looking at the negative part when we say the amplitude. And I really should up here, I'm going to put these absolute value bars. The absolute value, so the positive. So amplitude is 6. When you reflect it over the x-axis, it doesn't change the distance from the top to the bottom because it's an even amount. Like if you are the same distance on top, on bottom, and you flip it, you're still the same distance from on the top part and the bottom part. So that negative in front doesn't change the amplitude. All right, the period is 2 pi over b. My b is pi. So what is 2 pi over pi? Pi's cancel. 2. So that means the frequency is 1 over 2. And my vertical shift is 5. So it goes up 5. This one down 7. Any questions? So the graph of function h is shown in the figure to the right, along with information about the amplitude, midline, and period of the graph. So it just gave us, it told us the amplitude is 6, it told us the midline, and it told us the period. So amplitude, midline, we get easy. The period we're going to have to do a little work with. So I know already that A is what? 6. The amplitude is your A. The midline, or your vertical shift, D, is what? 3. Now, B is not pi. Remember, your period is not B. You set your period is 2 pi over B. So when I'm going from a graph to an equation, I've got to set pi equal to 2 pi over B. Well, long ways you could cross 2 pi b and divide both sides by pi. You're probably going to have be 2 because that's probably going to come up a lot. Amplitude, all that is. So the line is really the easiest to start with. Look, 0.0, so half what is right here. So my midline or my vertical shift the x-axis is your midline up 3. Line. And so what is your amplitude? It is also 3. And then for B, we need to figure out what the period is. Now really the period kind of starts, if you start at the midline and you trace up, down, you're going to stop back at that midline. So if you look at there what I've highlighted and versus what I've not highlighted, do you see that they're essentially the same thing? Like this chunk right here, if I were to cut that, and so what is, it is pi, which means my B is, it's going to be 2 again. Yes. So this is your A. This is your D. I don't like marking that as B. I would rather write pi equals 2 pi over B. Because if you just put a B there, later on you might forget and just start using period and B as the same thing. And they're not interchangeable. So if we start with the midline, it's going to be right here at -1. And so my amplitude is 2. The period, if I start here at the y-axis, I'm going down and then up and then back down. That is my period. So the length of that line is my period, which is pi. From 0 to pi is pi. Now if I wanted to find my B value, I would say pi equals 2 pi over B, and I would say, okay, well B is 2, but it didn't ask for B. That's not part of it. So okay. So number 6 is a question like we've done, except instead of us just telling what the period, amplitude, all of that is, we have to put that into the equation. So we have a maximum at the point 0, 6, and a minimum at pi over 2, -4. And so it will look something like this. The other questions, I like to start with like the amplitude and the midline. I think it's easier that way. So this entire distance from the whole top to the whole bottom, what is that whole distance? 10. Okay, but remember the amplitude is half of that. So the amplitude is what? 5. So we can get rid of those two answer choices. The midline is the actual line. That is 5 units between each point. So 5 units away from 6 is going to be at what? Or 5 units below 6? 1. Or you could say 5 units above -4 is also 1. So my midline is 1, which didn't help me out any. And then my period, so from 1 max to 1 min, it's not a full period. It's half of it. It's halfway. So from 0 to pi over 2 is half the period. So what is the full period? It's what? Pi. So what's my B?
No. Pi over.
So I would set pi equal to 2 pi over B. This is the exact same one that we done every time. I didn't do that on purpose. So what would B have to be? B is 2. So notice in these answer choices, it gave you an answer choice where your period was in the B spot. And that would be very easy to pick if you forget this. I want you to work on number 7. Choices B, C, and D look identical. What's the difference in them?
One's too high, one's higher, two, one's...
Like, yeah, if you look at the x-axis scale, like you had to look at the numbers and notice that the scale was different to pick these. Now A, I marked A right off because I knew it had a midline of -1. That was the first thing I checked. That was the easiest thing to check. And unfortunately, I was only able to eliminate A. So then I knew, okay, if B is 2, my period is pi. So I was looking for one that had a period of pi. So I started here and I traced up, down, up, 2 pi, no. Up, down, up, there it is, pi. The amplitude didn't matter, those were all the same. I would go check just to make sure. Up, down, up, make sure, because if that had said pi, then I probably would have been like, oh, okay, I need to check between these two and focus a little bit more. But we knew the period needed to be pi.
All right.